Good morning everyone. Electric field. It is a space around the charge where its influence can be felt. The word influence means exerting the force of one charged particle on other charged particle. If you keep one charge here, say positive charge, if I bring another charge close to this, any other charge, say small q, I will take it as a plus, repulsion will find. That is repulsion force acting on itself is called as influence. That means this plus capital Q is influencing the small q to move away by repulsion force. Instead, if I keep a minus Q, negative charge, then it will be attracted towards it. This is also influenced. That means around this plus capital Q, around this, in this area or space, it is able to exert force on other charges, either attractive or repulsive. That's called as influence is there on it. This space around this charge is called as a electric field. And this capital Q also has a space around it, small q also has a space around it. So every object has a space around it where it can influence other charges. So if capital Q is repelling the small q also repels capital Q away. According to Newton's third law, force is action and reaction. If this is exerting has action on this also exerts the reaction force on it. Okay. That means action reaction force are acting. Each one is exerting the force on other, influencing other charges. That means every charge has a space around it where it can influence other charges, that itself is called as an electric field. But from your textbook, some books, they mention electric field itself also as an electric field intensity. Both are actually different. Electric field intensity, electric field strength. Symbol represents this capital E, but some books, even in your textbook, also mentioned as electric field itself as electric field intensity as taken, but now no need to worry about this actual definition. Electric field is actually space around the charge where it can influence other charges. Electric field intensity is related to the force. Electric field intensity or electric field strength also can be represented as sometimes electric field itself. This is defined as the force acting on unit positive charge placed in the electric field. I take one charge. This is a capital Q, I will take plus Q. Around this charge, we said there is a field which can influence other objects. And this field is invisible to us. We cannot see what is actually present around this charge. But if you take another charge, this Q0 I am taking. In your textbook, this is given as a small q only, but I take it as a Q0. I take this another charge, Q0, which is a positive charge. This is called as a test charge. And this is called as a source charge. Capital Q is called as source charge. Q0 is called as a test charge. Test charge is used to test. Test charge is used to test whether there is a field here in this area or not. And test charge should be very small charge. Very small in magnitude, very small. If you say for example 100 microcoulomb, so this should be only 1 microcoulomb. Only 1 microcoulomb. Plus test charge is able to take it as a for definition purpose plus. Need not be always 1. It can be any values. It can be plus, it can be minus when you are calculating for the problems purposes. But definition purpose when we discuss now, Q0 is taken as a plus 1 microcoulomb, means positive, always, and very small compared to the bigger charge, which is called as a source charge. This is the source charge means what? It is providing electric field around it. It is providing electric field around it. This test charge is very small. It also has electric field, but very small compared to the bigger, large value of the charge. This one is having a very weak and small field, and this has very large amount of the field. Okay, and this called source charge. This called test charge is to test whether the charge field is there or not near the source charge. So electric field here what we are defining is from the source charge, not from the test charge. Electric field is defined as a force acting on the unit positive charge. Unit positive charge. This unit positive charge is nothing but a test charge. And then this is equals to plus 1 coulomb. When this is plus 1 coulomb, E equal to F only, force it. That is how we take the definition of electric field strength or electric field intensity. It is defined as a force acting on unit positive charge placed in the electric field. Okay. The definition is important and formula important for even for theory also, for the practice also. Definition for this: it is the force acting. It is a force acting on unit positive charge. Unit positive charge placed in electric field. It is a force acting on unit positive charge placed in electric field. So we write this electric field. This electric field is produced by the charge that is called as a source charge. For definition purpose, that need not be mentioned, but you have to mention separately what is that electric field is of. Electric field intensity E is equals to F by Q naught, where F is force on Q naught. What is Q naught? Q naught is called as a test charge. Test charge. And this E becomes equal to, if Q naught is equals to plus 1 coulomb, then E itself is equals to force. This is how we take the definition. Electric field itself is a force acting on unit positive charge placed in the electric field. Electric field is produced by because of the source charge. This electric field is because of the source charge, not because of test charge. Test charge is a small charge, which is electric field are there, but it is negligibly small compared to the source charge. Force acting on test charge, or you can take any charge. Force acting on charge Q naught. Q naught placed in electric field. Electric field E means that I mean is electric field intensity. E equal to F by Q naught. So cross multiplication if you take, F becomes equal to Q naught into E. Force F is equals to Q naught into E. Charge is a scalar quantity. Already we have discussed it before. Charge is a scalar. So in the equation, electric and force are vectors. Charge is scalar, and E and F are vectors. So E and F in same direction if charge is positive. But charge can be positive, negative, neutral means no, we don't consider charge. If Q naught is positive, this becomes equal to plus F. Plus means what for vector? So same direction. Electric and force are in the same direction for the positive charge. If Q naught is negative, minus comes. So equal to minus F means what? It becomes opposite direction. So F force is opposite to the electric field for negative charge, but in the same direction for the positive charge. Here F equal to Q naught into E. In vector form we can write vector form F bar equal to Q naught into E bar. In this, we will take subpoints. Electric field intensity, simply called as electric field also intensity. E is vector, and force F is also vector. E is vector. What about the charge Q naught is scalar? Instead of Q naught, you can take Q also. Just a small Q we can take. And in this point, important thing is, if Q naught is positive, Q naught is positive, then what you get here is F is equals to Q naught into E bar plus comes. F and E are in the same direction. Therefore, F comma E are in same direction. This point is important for us, means positive charge experience force in the direction of electric field. That point is important. Positive charge experience force in the direction of electric field. This E field I have mentioned for electric field. This point is important. In case if I take the electric field, we mentioned vector means arrows like that. This is the electric field direction right side, and Q naught here taken is a positive side. Then what is the direction of force acting on this Q naught is in the direction of electric field, means it experiences force. This is the electric field direction. So this is a plus Q naught. This experiences force in the direction of electric field. So it will try to help in the direction of the field. In this only if Q naught is negative, means negative charge again in the electric field, then what happens to the force F becomes equal to minus Q naught into E bar. In vectors, minus terms means F and A are in the opposite directions. So what I get here is therefore F is opposite to E bar for negative charge. Is opposite to electric fields for negative charge. We can also mention this as negative charge experiences force opposed to electric fields. Negative charge experience force opposite to electric fields. Opposite to electric fields. This point is important. In case you take the electric fields towards the right side, use a vector right side. But if I take the negative charge, Q naught minus, it experiences the force opposite to the electric field. So it will try to go in this direction. So if you take the protons and electrons in the electric fields, how do they move? Therefore, if I take electric fields towards the right side, this is the direction of electric field if I take. Then if I take the E minus, it experiences force opposite the electric field. But if I take a E plus means proton, it experiences force in the direction of electric field. This is for proton, this is for electron. What is source charge? Symbol generally take is capital Q, not fixed. We can take small q also. Okay, definition time only we take the small q for the test charge, Q or Q naught. But other cases no. After the definition cases, problems, etc. applications, we can take a charge means source charge can be small q symbol or capital Q symbol. Source charge capital Q. It is the large amount of charge which produce strong electric fields. This mentioned as a which produce strong electric fields. Which produce strong electric fields. Test charge Q. Not I am giving in the textbook, in your BU textbook or NCERT textbook, they are given as a small q, but I will give it as a Q naught for the test charge. it is a small amount of charge. How much we take generally for the definition purposes? Plus 1 coulomb we take. It should be compared to 1, it should be 100,000 like that take it up, and this one will take it as a plus 1 coulomb. It is a small amount of charge which produce negligible electric field compared to source charge, which produce negligible electric fields compared to source charge. When the electric field is small, automatically force is also small, because we are taking that E equal to F by Q naught. We have the formula for electric field intensity. E is equals to F by Q naught. This is modified now as E is equals to limit Q naught tends to 0. F by Q naught is called as a electric field. This is for understanding of the source charge and discharge relationship. Tending to 0, limits under the condition. Limits means within the limits or within the conditions. Q naught equal to becoming 0. This arrow mark indicates that tending to means become 0. Don't put 0. We should not put 0. Becoming 0 means what? Negligibly small. Very small we are taking. That's what I say. Tending to 0. Very small you are taking it. But it's considerable, not a 0 actually. Anything by 0 should be infinite, but it's not like that. We are saying that we are mean to say that its effect is less. Its electric field is less. When electric field is automatically it will not exert force on other charges. So what is the source charge here? Capital Q is the source charge, and this Q naught plus 1 coulomb, it is a test charge. This is very small size. This is a test charge. This is a test charge, very small ones. So when you keep these two charges, this is a plus 1. Charges nearby. This exerts a force on this, repulsive force. This also exerts force on it, but capital Q is a large value. It can exert more force on the small q. Actually, action reaction pairs compulsion should be equal. But compared to the electric field, if you check up, if it is a bigger ones, it cannot move easily. The smaller one easily can move. It's just like a football. If the person is taking the football moves easily. Person also experiences equal amount of force, but with the large mass, it cannot move freely. Same thing we consider here. This is larger value. This is a smaller value. Action reaction force are equal, but electric field produced by this is larger, produced by this is very small. Okay, but electric field in this area, at this point I want electric field because of source charge. The electric field at the source charge not because of Q naught, it is because of capital Q. So small Q naught cannot influence much other charges because its value is very small, electric field is very less. But capital Q electric field is large because the large value of the charge, it influences easily on the other charges. Can push this capital Q naught is small Q naught easily from the place. Okay. So in this case, this Q naught is very small, but F by Q naught is considerably present. It's not infinity, not 0, but it is present. That is called the finite value of the electric field. The electric field now we are considering not because of Q naught, only because of capital Q. That is understood by taking the condition that Q naught is nearly 0, means its influence is negligible. Okay. So this electric field here, E fields, depends only on source charge, capital Q, and not on test charge, not on test charge Q naught. Why? Because Q naught is very small, so its electric field is negligible. To understand that, this is only theoretical concept. We should not put Q naught equals 0 like that. It is only for understanding that Q naught is negligibly small compared to capital Q. Capital Q we don't mention here. We are just mentioning in terms of the force only it comes. Studying expression for electric field. Expression for electric field. Actually, here I need to say electric field intensity or electric strength only. Electric field is only space around it. It's not a vector. Electric field actually space means area. In this area, on this three-dimensional value, around this charge, if it is a charge, around this space, all this space, it can exert the force on other charges. So this area itself is electric field actually. But we are going to represent this electric field intensity sometimes termed as only electric field. But it's not electric field. It's actually we meant to say electric field intensity. We are talking in terms of formulas, in terms of the vector term. Expression for electric field intensity due near isolated point charge. Intensity may be mentioned simply as electric field also. Expression for electric field intensity near isolated point charge. Capital T. Expression for electric field intensity or electric field near isolated point charge. Isolated means except the charge, other charges are not present. We call that as an isolated charge. This is for 3 months. Important for 3 months graduation. Consider an isolated point charge capital Q in space, and I want the electric field distance equal to R. I want electric field at distance R, small r, from this charge in space. Space means the area where we are putting the charge, not on the table. Putting the table means other object is present. We are not imagining that. This is space. I am putting space need not be always outside there, not necessary. I am putting the charge here. Imagine no air is there, no objects are there, nothing is there except this cube. No table, no room, nothing. We have to take only imagination. That only that charge is there. That is meant by isolated charge in space. Consider isolated point charge Q in space. Let is electric field. Is electrical field intensity. Intensity at a distance R from capital Q, and we can take even capital Q as the origin also. We can take. Now what we put is we take the test charge Q0 at this point at distance equal to R. Keep test charge Q1 equal to plus 1 at this point. This. Then what is the formula for the electric field we have is electric field intensity. I'm just write electric field we are writing E equal to F by Q0. This is from definition. From definition of electric field. But already we know the Coulomb's formula for the charges. Now we have the two charges. One is source charge. This is Q. Bigger charge. Another one is test charge. That is Q0 equal to plus 1 Coulomb. The distance between these two is R level. Okay, that Coulomb force is acting between these two. What is the Coulomb force acting? F equal to Q into Q0. Q into Q0 by 4 pi epsilon into R square is the Coulomb's formula. This make this charge as positive charge, plus charge. Initial purpose, not compulsory fixed. Afterwards, we can take minus charge also, whatever we get. This is the computation. But Coulomb force F is equals to 1 by 4 pi epsilon into Q into Q0 by R square in vacuum. We are imagining first in vacuum. put this formula in this. Therefore, electric field becomes equal to, combine these two formulas. If you F is substituted here, therefore electric field intensity E is equals to 1 by Q naught into this value. Means this value you will take in terms of the force space and then into 1 by Q naught. Right? 1 by 4 pi epsilon naught into Q naught by R square into 1 by Q naught. However, getting the Q naught as 1 coulomb, if you have taken this, you can see no need to write also. But if it is not 1 coulomb also, we can write this formula and we can cancel this. So you get the expression for electric field result. Therefore, E becomes equal to 1 by 4 pi epsilon naught into Q by R square. This is the formula for electric field intensity near isolated charge capital Q. We are taking the modulus now from the definition basically of the inverse band also. So Q is positive. Whether Q is positive or negative, electric field should be taken in the sequence. Modulus positive only, we take the electric field. Don't take a minus charge is electric field minus 1. Electric field is a vector. Minus indicates opposite direction, plus indicates a positive direction in the proper directions or same direction. This in vacuum. In this Q is a source charge in vacuum. Because source charge is the electric formula. This in vacuum. In vector form also they are asking generally electric fields in vector form. If you take a vector form, we have to imagine that capital Q is at the origin. Then this R becomes equal to now R bar. And unit vector R cap is perpendicular in the direction of R bar.